Hi everyone, welcome to the second part of Pre-Calculus Lesson 7-2, Addition and Subtraction Formulas using trig functions. So we're moving on to some of the harder questions you will see in this lesson. So we're still working with those addition and subtraction formulas. I've erased the ones for tangent because we don't need them for our examples, and I've written up a different formula that we're going to be using later. Okay, and our first example says to write sine of inverse cosine x plus inverse tangent y as an algebraic expression in x and y, where -1 is less than or equal to x, which is less than or equal to 1, and y is any real number. Now, the reason they have to tell you this and this is just so that you know that you're not going to end up with an error when you're doing this. It's because of the domains of those two expressions. So that's why they had to tell you that, but essentially that's just to tell you that the question's going to work. So we can pretty much ignore that. So all we're going to do, I'm just going to get rid of it because it's not really important for what we're doing in solving this question. It's just telling you that this question will work. So in order to solve this, what I'm going to do is start out by looking at this cosine inverse x. And let me underline that in red, cosine inverse x. And if you recall, when we learned about inverse trig functions, what they do is when you use an inverse trig function, it's going to give you an angle measure. So I'm going to create a right triangle to represent that. I'm going to pick an angle to label as my angle measure. In this case, I'm using theta. I'm going to label this with theta here, so I remember that that's what I picked for that angle. And then I'm going to actually use this x to label the sides of my triangle. Now remember, cosine works on a fraction. This fraction is literally x over 1. So cosine, which is adjacent over hypotenuse, the adjacent side is x and the hypotenuse side is 1 because cosine is adjacent over hypotenuse. So I labeled that on my triangle. Now I'm going to use the Pythagorean theorem to find the missing side length. So I'm going to label this as an a, and the Pythagorean theorem says a squared plus x squared equals 1 squared. And solving for a, I would subtract x squared, and then I'm going to do a square root on both sides. So this is the expression for this side of my triangle. So this is the square root of 1 minus x squared. Now, if we had been given a quadrant, we could make sure that that sign matched whatever quadrant we're in, but they didn't tell us any quadrants, so we're assuming first quadrant. Okay, and then they'll have to just adjust x and y based on that when they get to this question. Okay, so that's the values for that first expression. I'm just going to outline this in red so I remember. If I'm dealing with this red, I use the red circled triangle. Now I'm going to make a different triangle for the tangent inverse y. So let me underline this in green so I know I'm using the green triangle. And let's make another triangle. Now you can pick any letters you want for these angle measures. I like using Greek letters because, well, most of the time when we're using trig functions, we use Greek letters. So I'm going to just put a phi right here, which is just a circle with a vertical line. It's a lowercase phi. And now I'm going to label my sides using the ratio for tangent. Tangent, this y is y over 1. Tangent is opposite over adjacent. So this side is y and this side is 1. And now I'm going to use the Pythagorean theorem again to find this one. I'm going to label this as c. So y squared plus 1 squared equals c squared. To solve for c, I would just do a square root on both sides. So c is y squared plus 1. Or, sorry, the square root of y squared plus 1. So that is my missing side. Now I'm going to circle that in green so I remember if I'm dealing with the green expression, it is this. So now I'm going to use the sine addition formula because what I've done is I've replaced this expression, and I forgot to write my angle up here. This is phi. I've replaced these expressions with their angle names. So I'm doing sine of theta plus phi. That's what I'm doing, and that's what I'm putting in my sine addition formula here. So this is sine theta cosine phi plus cosine theta sine phi. That's what I'm doing, and these values I'm getting from my triangles. So going to my triangles for theta, sine is opposite over hypotenuse, so that is square root 1 minus x squared over 1. Cosine theta, and I like to do theta first, and then I'll go back to phi and I'll fill in those values. So cosine here is x over 1. Now I'll go back to my phi triangle. Cosine of phi. Cosine is adjacent over hypotenuse, so that's 1 over square root y squared plus 1. Sine of phi. Sine is opposite over hypotenuse, so that's y over square root y squared plus 1. Now we're just going to multiply these fractions together. So when I multiply this together, I'm just going to get this square root over this denominator, and then plus xy over this denominator. Now these do have common denominators, so I can simply add these together to get the square root of 1 minus x squared plus xy over that denominator. And that is my answer for this one. Okay, so we're going to do another question that's very similar to this, but they gave us numbers this time. So here's my example. It says evaluate sine theta plus phi, given that sine theta is 12 over 13 in quadrant 2, and tangent phi is 3/4 in quadrant 3. So I'm going to start with sine theta, this fact here, and I'm going to make a triangle based on that. So I'm going to make a theta triangle right here, theta. Sine is opposite over hypotenuse. Oops, that's supposed to be a 13. And using the Pythagorean theorem, I would get 12 squared plus x squared equals 13 squared. This is 144 plus x squared equals 169. If I solve for x squared, I would subtract the 144 to get 25. So x is 5. So this side is 5. And I'm also going to label this with a quadrant number, Q2, just so I remember. And I'll put that in red so I remember. Theta is red. Theta is red. Okay, now I can remember. All the red stuff goes together. Now I'm going to do the same thing for phi. Tangent phi is 3/4, so I'm going to make a new triangle. Phi is right here, and you can pick either angle to be it. I usually pick the bottom right angle. I don't know why. Tangent is opposite over adjacent. If you use the Pythagorean theorem, you do 3 squared plus 4 squared equals c squared. So this is 9 plus 16 equals c squared, or 25 is c squared. So c is 5. Okay. Now I'm going to highlight all of my phi things in green. So here's phi right here. Tangent of phi was here, and this is green. And I should label that quadrant as well. So this was quadrant 3. So I remember. Now I'm going to put it into my formula. Sine addition, because this is sine of an angle plus an angle. Sine addition, I'm getting that from my formulas page. sine of the first thing times cosine of the second thing. And it's plus cosine of the first, sine of the second. And now I'm going to put in values from my triangles. But before I do that, I'm going to write up here, to help me remember quadrant 2 and quadrant 3, all students take calculus. And my green triangle was quadrant 3. And my red triangle was quadrant 2. Now I'll put in values from these triangles. So, sine of theta. Sine is opposite over hypotenuse, 12 over 13. Cosine of theta was adjacent over hypotenuse, 5 over 13. Now, we're in the red triangle. Sine is positive. Cosine will be negative. Now I'll go to my green triangle. Cosine from this, adjacent over hypotenuse, so that is 4/5. And sine is opposite over hypotenuse, that's 3/5. Now I'm in the green triangle, that's the third quadrant, so these are both negative. Okay. Now I just multiply this out. 12 times -4 is -48. 13 times 5 is 65. -5 times -3 is 15. 13 times 5 is 65. They have common denominators, and I never reduce these fractions because chances are you're going to get common denominators if you don't reduce. So I leave them until the very end to reduce. -48 plus 15 is -33 over 65. And that's my answer for that question. Now we have one last question to do. It says express 3 sine x plus 4 cosine x in the form k sine x plus phi. Now I'm going to bring up my sum of sines formula here. That's this guy right here. So what I'm going to do is I'm going to identify A and B from what they gave me here. So A is attached to sine and B is attached to cosine. So up here I know A is 3 and B is 4. So I'm doing that first. Then in the formula, I'm going to solve for K next. K is the square root of A squared plus B squared. So K is the square root of 3 squared plus 4 squared. 3 squared is 9, 4 squared is 16, 9 plus 16 is 25. Square root of 25 is 5. So K is 5. Now I need to find phi. And they gave me 2 different formulas for phi. Cosine phi is A over K, and sine phi is B over K. And what I'm going to do with that is I'm actually going to put in the numbers I have. So 3 over 5 for cosine phi, and 4 over 5 for sine phi. So cosine phi is 3/5. Sine phi is 4/5. Now to solve for phi, I'm going to use my calculator. In the calculator, I type inverse cosine of 3/5. And I will also type in inverse sine of 3/5. If you get the same answer, that's perfect. That means you did everything right. If you don't get the same answer, double check what quadrant this might be in, because it probably means that you're in like quadrant 2 or quadrant 3, probably quadrant 2 if I had to guess, because that's where sine is not defined, but cosine is. So cosine inverse of 3/5 comes out to be, when you're in degree mode, I like to use degrees for this because it'll come out to a nicer number, but you can use radians. So it's about 53.1 or so degrees. You can use radians. If you got radians, it's 0.927 or so. Sine inverse of 3/5 is, oopsie, I copied it wrong. This was a 4. Of 4/5 was 53.1. Okay, so phi is definitely 53.1. Now, all I have to do is take my phi number and my k and put it into the format. So it's 5 sine of x plus 53.1 degrees. And that is my answer for this. So that's basically everything in this lesson. Please let me know if you have any questions.